actually managed to.
Why would you write that?
Okay, if you can't see why the pink rule sheet won't work, like if you're like, why doesn't this rule work, please raise your hand and ask. Usually it's pretty simple because the pink sheet has simple rules. This is just too complicated. I mean, there's x's all over the place. And so first thing I'm going to do is pull out the multiplying constant. So I rewrite like this. This is equal to negative 60 antiderivative x squared divided by 4x cubed plus 5. Question? Please.
Why don't we pull out the 4 and 5?
Oh, good comment. All eyes on me. Everybody, hold on. Ticket-worthy question. Okay, remember this. You can only pull out factors. Factor means this times this. So let me back up a step. This, like the 4 isn't a factor of the denominator because the 4 is only being multiplied by the x cubed. If it were a denominator of like 4 times stuff, then you can pull out the 4 as a bottom factor. The top is factors, 60 times x squared, so I can pull out the factor. So it's always back to, that's why I hate this word, because everybody just gets mixed up on what really divides. You only divide factors, you only pull out factors. Is that okay for now? Oh, I gave you a ticket, never mind. Did I give it to you? Oh, sweet. Go.
So if like x cubed plus 5 were in parentheses, then you can pull out the 4?
Yes, and I would.
Okay.
Yeah, if this were parenthesis 4 like so, 2 for Carson. Yeah, now the 4 on the bottom is a factor, and I would pull out the 60 and the 4 and actually divide them. They become 15. So you can only divide factors.
Could you do the same except if it didn't have a 5?
Oh yes, thank you. No, 2 for Justin as well. So if they had this, we're good again, because the top and bottom are all factors. We can just divide and just pull out a 15. Good questions. Okay, cool. Let's kill all that. So we now have this. Okay. To use a U substitution, except for an exception here, they're looking for 2 functions that are multiplying. So here's what I see. I see 1 over 4x cubed plus 5. I also see x squared over 1. So I do see 2 functions being multiplied. Questions? Please ask.
When you do that, is it best to end up with 2 being multiplying that? Like one has a numerator, one has a denominator?
It'll vary from problem to problem. That's common, but you'll also see a lot of situations more like this, where there's no denominator. The 2 functions that are being multiplied are this times this. So you'll see both. Does that make sense? Yeah, when I see division, I just change my view to multiplication.
Okay.
Does that answer your question?
Yeah.
2 points. Okay, now I gotta remember, just like the pink sheet, I'm looking for the 2 functions to be of the form something to a number, 1 over something, e to the something, sine or cosine of something. Right here, I see something to a number. And I'm looking at the something. The something is x. It's not going to work to say u equals x. So I ignore that. This is 1 over something. That's okay. U could be 4x cubed plus 5. That's 2x squared plus 1's little sister. So that was a bad joke. Okay, question. Shoot! Sorry, I was distracted by the joke. Questions? Stupid. Is that pretty good? Awesome. You differentiate both sides with respect to x. It's easy. Look, you see a dx here, has to be a dx here. It's dft here, it's going to be dft here. It's the symmetry, right? We're talking about how, you know, if we take a derivative, we get to here, we want an antiderivative, go back. So here it's the derivative, here it's the antiderivative. So this becomes, say it out loud, please. What's this? Louder? Louder?
12x squared.
Okay, in a moment, I want you to say yes or no, or wait for the prompt. When you look at this is what Justin was talking about. And you look at the other multiplying function, you can ignore a multiplying constant. Are they the same? Yes, that's good news. That's what we want. Question. So you just keep going now. Move the dx over. Move the 12. Questions? Now we start making substitutions. So this side becomes, oh, by the way, all I pencils down for a second, look at me. Look at me. Holly, look up for a second. Lizzie, look up for a second. Kennedy. No worries, just don't want you to miss this. Because of the somewhat complicated nature of this process, here's somewhere where I have to be very strict. You have to show your work how I am showing it. Now, if you get better and better, you can start leaving things out. So I trust all of you. Like, we're all the way into February almost, and you've learned that you have to have good notation. You've learned the value of it. You know on the FRQ how it's important. So I trust you to write what you need to write. Like, you can skip things, but it's got to be organized. This is your kind of scratch work, where you're trying to figure out the value of u and taking the derivative. This is the actual solution to the problem. On your paper, it needs to follow this pattern. Otherwise, if you ask me for help, I won't help you. It's too hard for me to try and decipher whatever pattern you came up with. Okay? Okay? It's kind of like turning an English paper with a whole new alphabet. And telling your teacher, well, it's my alphabet. I like it. Never mind. Jokes are really bad today. Okay. Come over here. This is negative. You guys, the jokes are bad every day. I get it. This is 1 over u. This is just 1/12 du. The problem has become exactly the same as the previous. One difference, we have to leave the absolute value bars because the term inside the absolute value is a cubic, not a quadratic. Question. If you take the derivative of this, you will get this. Because we have just found the antiderivative. Again, the expectation is when I see you on Fridays, when I walk the room, you should be telling me, I got through the whole homework sheet, but I did get stuck maybe here or here. I do think if you just check the videos, though, you should be able to get unstuck. Oh, because you can only pull out constant factors. So right here, Elena, these three are factors because they're stuck to be multiplied. But one of you is on a constant, so you can't take it. Makes sense? Sorry. Yeah? Yes. Because u is really 4x cubed plus 5, and that's going to be any number of negative infinity to positive infinity. So constant means 1 over 12 is never going to be anything but 1 over 12. This could be all kinds of yeah. Oh yeah. So I'll